And now on to one of the important ideas in calculus, the limit of a function. First, an example. Suppose that you have the function f of x is equal to 1 over x squared. So what happens if x equals 0? Well, if you have x equals 0, the bottom would be 0 squared, or in other words 0, and that is undefined. 1 divided by 0 is undefined. So instead of saying what happens when x equals 0, we have to change the question a little bit. What happens when x is close to 0? So you could look at it with the graph, or you could look at it numerically. So we could look at a table of values. This is going to be x, this is going to be y, and then right here is if you put 0 itself, the function is undefined. And then over here, I'll pick some negative values, and over here, I'll put some positive values. So like a 0.01, a 0.1, and a 0.2. On the other side, negative 0.01, negative 0.1, and negative 0.2. So how much do those y values equal? So for this one, I need 1 divided by, and then put a negative 0.2 in parentheses and square that. And it equals a 25. 1 divided by a negative 0.1 and square that, and it equals 100. It's even bigger. And 1 divided by a negative 0.01 gets squared, and now that is actually 10,000. So what about the positive values? Well, it's going to turn out to be the same thing, because when you square the negative, it's going to be a positive. So when I square the positive, it's also positive 10,000. And then this would be 100, and this would be 25. We could also look at it graphically. So y equals, and then clear out this old function. And this one is 1 divided by x is squared. And then the fastest way is just go to zoom, standard, or zoom number 6. And notice if I put trace and plug in 0, it's a blank right there. That's because division by 0 is undefined. But then what's happening to the function is this side is getting bigger and bigger, and it's going up to positive infinity. And this side is getting bigger and bigger and going up to positive infinity. So here it's getting bigger and bigger and bigger the closer you get to 0. The other side is doing the same thing. It's getting bigger and bigger and bigger. So both sides agree. They both say that the function is going up to positive infinity. And of course, I could write all of that in words, but in math, we like to use symbols. So first of all, what happens as x gets close to 0? So the way to say that in symbols is x, arrow, 0. So that's not saying equals 0, it's saying that it's close to 0. And what this means is you should check the left side and also the right side of 0 and see if they're doing the same thing. And here they are. And what we just found is called a limit. And for limit, we just use abbreviation LIM. And then you tell it what function you're talking about, 1 over x squared. And now take this part, x goes to 0, and that goes under the LIM. And then the answer is that both sides are going up to positive infinity. So an important note. If you're going to say that the limit as x approaches some number equals a limit L. So that would mean that, let's say A is right here and L is right here. Then when you come from the left side and you get closer to when x equals A, then the y value has to be L. And when you come from the other side, this side has to agree and it has to end up at the same place. So the way to say that is on this part right here is x approaches A. So on the left side. So right now I'm on the left side of A and I end up at the answer L. Well, to say the left side, you just put a little negative up here as, as an exponent, and that means the left side. And so on the left side, you'll get the answer L. And to indicate you're talking about the right side, so in other words, when you're on the right side of A, you get the same thing. That's going to be A with a little plus. So the left side and the right side have to agree, and then the answer is L. Like in here, the left side and the right side both went up to positive infinity, and so the answer was positive infinity. So then for example number 2, let's say that the function looks like this. So right here is x equals 3. And the function goes like this, and then it's got a closed circle right here, and the y value is 1. And then let's suppose that the other side looks like this, and it's got an open circle, and the y value is 2. So the limit as x approaches 3 on the left side, and I forgot to label it, but this is f of x. So this does not mean negative 3, it means you're on the left side. So here's 3, and I'm on the left side. And then as you follow the function and you get closer and closer to when x is becoming a 3, the y value is becoming a 1. And the limit as x approaches 3 on the right side. So that would mean go to the right side of 3, so pick something over here on the right side, and then follow the function, and then it's getting closer and closer to when x is a 3, and the y value is becoming a 2. And it doesn't matter that there's an open circle right here, because this is not saying x equals 3, it's saying it's getting closer and closer. So as you get closer and closer to that open circle, the y value is getting closer and closer to 2. And then for the limit as x approaches 3, then we say it does not exist. Because as I was just saying in the last one, the left side and the right side have to agree. If they don't agree, then we say it does not exist. And then for does not exist, you could also abbreviate it with DNE. For example number 3, what's the limit as x approaches 0 of 5 over 1 plus e to the x? Now sometimes you don't need a table of values. Sometimes you can just plug in the number 0, or in this case 0. So with limits, you can always try that first. Just plug in the number, and if you get an actual number out, you are actually done. So with this one, it's going to be 1 plus, and then let x become a 0. Well, e to the 0 is equal to 1. So that means this is 5 over 1 plus 1, or in other words, 5 divided by 2, or that is 2.5. So that seems to be the answer. Now, if for some reason I would have gotten undefined, that doesn't mean there's no answer. It means I need to do something else. In here, I got a perfectly fine answer, 2.5. And then I want to verify with the calculator, make sure that I got it right. So go to y equals, and then graph 5 divided by parentheses 1 plus, and then the e is over here on the left side, so you need to put second e, and then x is the variable. And I can start by going to zoom standard or zoom number 6. And it seems like it's a perfectly well-behaved function. And we were talking about when x is becoming a 0. So I could try on the calculator, trace and plug in 0. And it says, actually, you were right. The answer is 2.5. So now I can put a box around this one because it's done. Then for example number 4, what's the limit as x goes to infinity for the same function? So if this is becoming infinity, then this is e raised to infinity, which means e times e times e times e, and you do that an infinite number of times. So this is going to become e to the infinity. And then e to the infinity is equal to infinity, and if you add 1 to infinity, it's still infinity. So this is becoming 5 divided by infinity. So this would be like if you had $5 and you shared that with an infinite amount of people, how much does each person get? You're right, nothing. So 5 divided by infinity, that's 0. And if you look at the graph, when x is going to infinity, that means follow the graph out to the right. And what's happening with the y value. So if you follow it to the right, you can see that the y values are getting smaller and smaller and smaller until they're basically so small, the calculator rounds it to 0. So this one is done. Okay, then on to example number 5. So for this one, we're going to have the limit as x approaches 0, and the function is sine x divided by x. So if you try and substitute 0, so this will say sine of 0, which is 0, and then this will be 0, which means it's 0 divided by 0. As far as limits, that basically doesn't tell us anything. That means we need to try something else. When you get 0 divided by 0, the answer could be absolutely anything. So use a table of values to estimate the limit. So you can make a table of values yourself and do things like sine of 0.1 divided by 0.1, sine of 0.01 divided by 0.01, and then write down these y values. Another way to do it is have the calculator do it for you. So pretend like you're going to graph it. So y equals, and then sine x divided by x. And then if you look at right here in blue, it says table set. So go to second table set. And then where do you want to start? So I'll start at negative 0.2. And then go up by point. So this delta right here, the little triangle means change. How much do you want it to change by? So change by 0.01. And then just leave these as automatic. Auto and auto. And then right here is table. So go to second table. and then it will make the table of values for you. So I need to get a little bit closer to 0. And it says if you actually have the 0, then there's an error. But when you're close to those values, so I'll just pick 3 on either side. So at 0 itself, it's undefined. And then pick 3 on either side. So 1, 2, 3, so that would be negative 0.01, negative 0.02, and negative 0.03. And at least as far as 3 decimal places, it's rounding it to be exactly a 1. And on the other side, use positive 0.01, positive 0.02, and positive 0.03, and those also seem to be a 1. So it seems like the answer is 1. Then also take a look at the graph. And I should go back to zoom standard. And so right there, it looks like the y value is 1. So if you trace and pick something even really, really close to 0 for x, it's going to say the y value is 1. So my conclusion is the limit as x approaches 0 for sine x over x, the answer is 1. Then for example number 6, what's the limit as x approaches 3 for x squared minus 9 over x minus 3? So if you substitute a 3, this will be 3 squared. So in other words, 9 minus 9 is 0. And then this would be 3 minus 3, which is 0. And like I said before, 0 divided by 0, the answer could be absolutely anything. So we need to do something. Now with this one, with the sine x over x, there's not really any way to simplify it or anything like that, so we needed to use a table of values. But with this one, we could actually do some algebra. So what you could do is factor the numerator into x plus 3 times x minus 3. So this one is the difference of squares, so you can just factor it x plus 3, x minus 3. And then it turns out x minus 3 shows up on the top and the bottom, and then they cancel. So this is good news, not only because it makes the problem simpler, but if you plug in 3, this would be 0, and this would be 0. So right here, we actually just canceled out the 0 divided by 0. Now that that 0 divided by 0 is canceled out, you can just plug in that x is going to become a 3. So it's going to be 3 plus 3, which is 6. And then to verify that I got it right, graph the original problem. So this one right here, x squared minus 9 gets divided by parentheses x, parentheses, x minus 3. And then zoom standard. So we're talking about over here when x is equal to a 3. Well, notice that if you go trace, nope, that makes the glare worse. Notice that if you go trace and you plug in a 3, it's going to say undefined. But if you pick a number close to 3, like 2.999, then it's going to say your answer should be very close to 5.999. And if you pick a number on the other side, like 3.001, it says your answer should be very close to 6.001. So now I'm convinced that I got this one right. Okay, then just for one more example. So for example, number 7. So with this one, you're not given f of x, but graph it with this limited amount of information. So f of 0 equals -1, f of 3 equals 1. The limit as x approaches 0 equals 1. The limit as x approaches 3 on the left equals -2. And the limit as x approaches 3 on the right equals a +2. So create a graph that has all of these properties. So the first thing that I do is I look at all the x values. We've got 0 and 3, 0 and 3. So we need 0 and we need 3 on the x. As far as the y values, we've got 2, -2, 1, -1. So we can go 1, 2, -1, -2. So this is actually giving us an x and y point. So 0, -1. So there's a point right there. And then this one is 3, 1. So 3, 1 would be right here. Then I'm done with these two. Now the limit as x approaches 0, and this would mean both the left and the right side, are going to reach 1. So when you come in from the left, it's going to equal 1. When you come in from the right, it's going to equal 1. So that takes care of this one. Now as far as the 3. So on the left side, the y value is going to become a -2. So a -2, that would mean that it's about right here. Because this already has a closed circle, right here I'm going to need to use an open circle. And then just continue the function down until the y value is right there at -2. Then for the right side of 3, so it should be up here at +2. So put +2, an open circle, and then just create a function. And there we go. That one is finished. I know I said that was the last example, but there is one more that I want to do. Example number 8. Suppose that you have this piecewise defined function. So its graph is going to be 2x plus 1 if you're to the left of 1. It's going to equal a 4 if x is between 1 and 2. And then it's going to use x squared if x is to the right of 2. And then based on this, find the limit as x approaches 1, and also the limit as x approaches 2. So the first thing I'm going to do is sketch a graph to see what's going on with this thing. So x equals 1 is important, and 2. This part is saying the left side of the graph, you should be using this function. So the left side of the graph, so to the left of 1, we're using, this is a straight line with +2 slope, and it's crossing the y-axis at 1. So it's going to cross the y-axis at 1, and it's got a +2 slope. So it's going to be going like this. And then because this does not have an equals, then this should have an open circle. And if it's very close to 1, This would basically be 2 times 1 is 2, plus 1 is 3. So this y value right here is 3. Now in the middle between 1 and 2, you just make a horizontal line at 4. So between these two, it's going to be a horizontal line at 4. And then this one does have equals and does have equals, so this is going to be a closed circle, and this one's a closed circle. And for the right side, we're using x squared. X squared is a parabola, so that would actually be a parabola that goes like this. Although I'm not going to be using the whole thing, I'm only going to be using the right side of it. And 2 squared is equal to 4, which means that the parabola would actually be right here, and then it would be going up like this. All right, now I can visualize what's going on. So on this one, to answer this question, the left side and the right side do not match. That means that the limit as x approaches 1 does not exist. Ne existe pas. But for the limit as x approaches 2, so these two matched up and they agree right here. They agree that the y value is 4. Okay, now we're done with section 2.2.